We've come to our final presentation. This will be handled by two presenters, both from Crystal. We have Roger Franklin, he's president and CEO, and also Alan Young, who's the chief operating officer. But first we'll hear from Alan Young, the good-looking one. Just ask him.
Thank you very much. So, again, welcome to the last session. Sorry, I've just been told I've got to announce my topic. So we're going to talk about out-of-band SCTE 35 data. This is where the real world and recommendations don't align. And this presentation is going to be in two parts. I drew the short straw, so I get to talk about the problems and issues. And Roger, who's the CEO and cut the straw, gets to talk about the solutions. Okay, so how do I move this thing forward? So SCTE 35, for those of you who don't know, is basically a 2-decade-old standard. It is one of the standards that supports a very important revenue source for our industry, advertising. Almost all distributors rely on SCTE 35 signaling, which is sent in band with the television transmission to provide the cue signal to signal when it's time to insert an ad. And it's been used, as I said, for a couple of decades now for the local commercial insertion breaks at cable operators. So this is the 2 minutes an hour that's typically granted by the cable networks and broadcasters to the distributors so that they can insert local ads. More recently, however, though, the standard has been extended to support a variety of applications for over-the-top and TV everywhere providers. And these are things like dynamic ad insertion and content replacement or blackouts, start over TV, look back TV, network DVR, and live to VOD. And there were presentations about that earlier today, live to VOD. So, a cable standard for OTT. SCTE 35, after multiple revisions and additions, can now be used to signal the start time and the duration of just about every segment in a linear television program. So we're talking about the start of the program hour, the start of a program chapter, the start of an ad break, the start of an ad, and many, many other things, even overruns, breakaways, and overlaps. In fact, there are 28 different types of signal defined in the current standard. There were 26, but they added 2 in the last revision. And basically, this allows the linear television signal to be conditioned, and I'll talk about what that means in a minute, so that it can be manipulated seamlessly, and that's important. So seamlessly means so that the user, the end viewer, can't see the difference in an automated fashion. And the automated is very important because with so many different distribution paths now, if you can't automate the insertion of these ads and the delivery of the content, as well as the creation of live to VOD assets, you're just not going to be able to scale. And so the automation component of this is very, very important. So SCTE 35 is really a critical standard when it comes to allowing the monetization of over the top. So what is conditioning? So at the top there, you'll see a typical program half hour. You have your program segment in blue, and then you have your national ad breaks, and your local break, and even individual adverts delineated. And so what happens when that's converted for OTT delivery is it's broken up into fragments, and these are files so that it can be sent over the internet. Actually, they're sent, they look like, they're sent over HTTP, so they look just like a web page to most of the equipment, which is the whole point. And the idea is that for each segment that you'll find in the playlist, that you want to end up with an integer number of fragments that exactly represent that, frame to frame, that program segment. Each fragment really should start with an IDR or a keyframe, and the idea of that is so that you can start playback at that precise point. And the idea being that ends up being the first frame of the first segment. And you want to close off the group of pictures, the GOP, at the end of each fragment. And of course, this is all nicely aligned with the content boundaries. And the benefit of doing that is that you can seamlessly manipulate that content by manifest manipulation. So the manifest is the list of files. It's a bit like a playlist that's sent along with the content. And then you can, very simply by rewriting that manifest, move those files around. So you can move, change, you can remove ads in a VOD file. It's very simple to manipulate, and of course the beauty of this is you don't need any broadcast engineering knowledge if this is done properly right from the start to manipulate something and make it look seamless and professional. And you can dynamically replace content, which is important if you need to black out content because you don't have the right to transmit it over the internet, for instance. The whole point of this is that this is all based on the SCTE-35 timing data that is sent with the video as it's originated. If that gets compromised in any way down the path, then you're going to have a problem, further downstream because you won't be able to condition the content properly. And so, one of the problems with SCTE-35 is that there are many interpretations. And in fact, Crystal's business, is largely based on providing the SCTE-35 metadata for our broadcast clients. And no two of the implementations from broadcasters are the same. There's a recommendation called SCTE-67, which was written specifically to help people understand and interpret the SCTE-35 spec, but candidly it hasn't really helped. It is a recommendation that everyone follows, yet they all come out with different results. And that's a real problem because there's a huge amount of legacy equipment. I told you right at the start that virtually every distributor uses SCTE-35 today. And so there's a lot of legacy equipment, there's a lot of legacy systems, and frankly a lot of legacy opinions on how it should be done. And this has become a massive issue for distributors. It's very difficult for them to understand exactly what's being signaled, and I've got some examples which I'll show you in a minute. And as a result, it's severely hampering the utility of the standard, and therefore the ability to monetize the content in the OTT world. So the next three slides are real example profiles of SCTE-35, and I'm not going to go into the details about the colored dots, other than to show you the differences between them, and then I hope I can go back. So you can see these are three real examples, but they're very different. And if you notice on this one, the blue dots at the beginning of the national ad break and the yellow dots, there's a blue dot at the beginning of every advert in this one. In this one, there's a blue dot at the beginning of the ad break. And that is because these two broadcasters interpret a provider placement advertisement start signal as the start of the ad, and the other one interprets it to mean the start of the ad break. So as you can see, there's a little bit of confusion there if you're the distributor trying to interpret what that means. And some will only signal the breaks. They won't signal the individual ads at all. And they'll use different signaling that's not used anywhere else. So there are, and I could go on and on and on here, there are multiple formats and multiple ways of signaling essentially the same thing. So in terms of how to deal with this, one could say, why don't you just standardize the, what every broadcaster does? And that's definitely part of the solution. But there's a much bigger issue, actually, with 35 that really needs to be solved first. And that is that the timing information, which is so critical in a SCTE 35 message, needs to be preserved all the way through the transmission chain. So if the PTS timestamp in SCTE 35, which points at the precise frame that it's referring to, is not properly processed as the video is processed, you're going to have an error. And this is very common in transcoders. You'll find that the transcoder vendor will first decompress the video, and then they will recompress it. And in doing so, the PTS changes, and then they do not subsequently change the PTS in the SCTE 35 packet. They merely just pass it through. And if that happens, then the timing has been lost, and essentially it's been lost forever at that point. And so that is a problem that is really starting to hurt the utility of this valuable standard. In terms of how SCTE 35 is implemented today, there are basically two ways of doing it. The top workflow is using contact closures. Yes, it's still used today. GPI or general purpose interface, contact closure, the automation system. The broadcaster will put secondary events in the playlist, which are set to trigger a particular GPI. And then inside the SCTE injector card, there are canned messages. So they might say start of program, or start of ad break, or start of advert, so on and so forth. And that can either be done directly as SCTE 35, or it can be injected as SCTE 104, which is the baseband version of SCTE 35. And so the idea is a compression encoder for distribution will convert 104 to 35. The other way of doing it is a direct IP integration. So the system will read the playlist. There's no need to put secondary events in. And the advantage of the IP integration is that you can dynamically insert asset IDs into the SCTE 35 package. You cannot do that with the top one because the messages are canned and they're the same every time. And so you end up with the SCTE 35, and then that gets sent off to the OTT distributor who transcodes it, and hopefully they preserve the SCTE 35 data through that transcode process. But there are a couple of problems which I'll talk about on the next slide. One is with the 104 to 35 conversion, and then of course the transcoder, which I already mentioned. Conversion from 104 to 35 is not always performed correctly. Compression system manufacturers do not always keep up with the spec. The 35 spec has been modified multiple times, and compression manufacturers, quite frankly, just haven't kept up. So you find people that will truncate part of the messages and other errors. And transcoding, as I mentioned before, is a particular problem where you lose the timing. And once you lose the timing in SCTE 35, you may as well just go home because it's not, nothing's going to work downstream after that. So at this point, I'm going to hand over to the long straw guy, Roger Franklin, our CEO. Thank you.
Thank you, Alan. And one of the ways in which we got to this point is the companies that work on this particular standard look at use cases. What use cases can they envision, and how do we implement those use cases and communicate those use cases down the line using this standard? In fact, we just had a request come in 2-3 weeks ago from broadcasters in the Netherlands that have asked for 2 more segmentation descriptor types to go from 28 to 30 because they envision a different use case. So in looking at a solution, yes, normalizing what a distributor needs to see is certainly part of that solution. But because we cannot envision all the use cases out there, we cannot put together a complete standard at this point in order to communicate absolutely everything that the industry wants to do in the future. So what Crystal's done is we've taken a look at this problem and said, how do we communicate the metadata that's necessary to enable the use cases we know of today and potential use cases that we will think of in the future that will survive the entire transmission path? And you know, when you get into a cable operator plant, things get decoded, re-encoded, transcoded, and converted all the time. How do we minimize the opportunity to lose that metadata or have it corrupted? And so what we have done with this is we've thought, how do we keep the metadata in sync with the video? Understanding the precise timing of where we are in that video is the key element of how we stay in sync and transfer metadata throughout the distribution chain and in an out-of-band method. If the metadata and these markers are not stuck in the video stream itself, they can't get corrupted. So if we send them out of band and resynchronize them with the video further down the line, we can accomplish the mission we're out to accomplish, which is to successfully deliver that metadata at any point during the transmission chain. What we've looked at is what is always included in band. Well, video and audio are always there. If that's not there, we've got even bigger problems. So fingerprinting technology has been around for a long time. What Crystal's done is looked at temporal fingerprints and figured out that very easily we can determine when a scene changes. There's not a lot of processing power involved in that. When there is a change of scenes that happens every few seconds in most videos, we can take a fingerprint that looks at the difference between 2 specific frames of video, mark the time when that occurs, that's the wall clock time, as well as time from the beginning of the segment, record that. We do it again when there's another scene change. We do it again when there's another scene change. And what we get is a series of fingerprints that are spaced out in time. And the time between those fingerprints is going to be extremely consistent, but unique. So if we run that same algorithm downstream and we look at those fingerprints when there's the same types of scene changes and we look at the time between those fingerprints, we can then align and know exactly where we are within a particular video segment. So not only are the fingerprints unique, but the time difference between fingerprints are also unique. We don't have to have every frame fingerprinted. We just have enough so that we can synchronize on a time basis and continue to check that. If there's a significant shift, we know the video changed, we know something happened. But in this way, we know where we are in the video. And once we know exactly what frame we're at, that's when we can start reapplying the metadata. Since Crystal interfaces to the playout automation system where this video is created, we know where the segment boundaries are, we know what metadata needs to be associated there. Where does a particular segment start? What's the ID, either ad ID, IDER, asset ID? What is in that particular segment? And what is the time of day, the wall clock, or the beginning of the segment time for that time of segment? So if we know a segment starts at 1 minute 33 seconds and 48 milliseconds since the beginning of the segment or since the beginning of the hour, and that is, in this case, example, 33 milliseconds after a particular fingerprint. When we see that same fingerprint, we know we're synchronized. We know that 33 milliseconds after that same fingerprint occurs, we need to reapply this metadata. Understanding the transmission delay is what allows us to extract metadata at the beginning and reapply it downstream. We also happen to know that the video passes intact and gets there safely, which is an added benefit. Now, a number of years ago, when folks were getting more comfortable with fingerprinting, transmitting certain data and metadata through the internet was not very secure or trusted. These days it is. And being able to extract those metadata markers, that timing information, the content IDs at the beginning, at the source, and distribute them down to receivers at specific points through a cloud-based delivery method, we can ensure that the metadata reaches the endpoint before the video gets there. There are enough video encoding delays along these transmission paths that we have the time to distribute this metadata before video reaches the endpoint. When we're looking at the entire playlist on a video segment or a video program, we can send these metadata markers down well in advance, 20 minutes, 30 minutes, an hour, 2 days, whatever we have access to in the playlist. And that gives decision servers at the far end time to figure out what they're going to do when the content reaches them and when they get that mark that says this is where a particular segment begins. Are they going to do a dynamic ad replacement? They've got time to run through the algorithms to understand which ad they want to replace with another ad. We can also communicate a significant amount of additional metadata that doesn't fit into a SCTE-35 packet or frame. There might be rights associated with particular ads. This ad must be replaced. This ad can't be replaced. This ad has to go at the front of the pod. This ad cannot go in conjunction with a competitor's ad. So there's all types of metadata associated with each video segment that doesn't fit into a SCTE-35 marker. There is SCTE-224, which is a standard available to communicate a lot of that information today. And the timing markers can reference those points in the SCTE-224 so that we understand what the business rules are behind each segment. But the idea is, we have some customers in the Netherlands that actually wanted to put, Dimitri, correct me if I'm wrong, but they wanted to put about 4,000 bytes of data into a SCTE-35 packet. Understand you want to send more data there? It doesn't make sense to put it all down there. But since we skip the encoding process, skip the decoding process, skip the transcoding, we can deliver that metadata safely. What else can we do with this? Understanding where we are within a video segment, within a video program to the frame. We can start to do all kinds of interesting things. We can apply graphics at the downstream point. The same graphics we put on our broadcast television signal may not work on a smartphone. My eyes aren't good enough to see the crawl of Fox News or CNN when it's on a smartphone. Why bother wasting the space? If I as a user want to be able to punch up player stats, give me the option to do that. So being able to deliver a much broader range of metadata downstream is possible when we know exactly where we are. Essentially, this is taking our playout system and distributing it throughout the network and giving the user, the viewer, some control over what they end up seeing. We also get some idea of, did the right video get to the right spot? Are we seeing the right fingerprints on the right channel in the right order? Are we seeing the right closed captionings? Do we need to deliver closed captions out of band because the user wants to pick a different language that is unique to them? So understanding exactly what gets delivered where and when, provide some feedback to broadcasters and assurance that they did indeed send what they expected to send and deliver what they expected to deliver. Again, with synchronizing video, understanding where we are in the video chain makes it possible to take two different playout scenarios, two different playout systems from different manufacturers, bring the output of those together, synchronize them, and be able to sliplessly switch between one or the other. This is going to be useful when we start moving playout to the cloud, but we're not quite ready to commit entirely. But hey, you want to run between 12 midnight and 5 o'clock in the morning from the cloud and switch back at the beginning of 5 a.m. news. You can do it all day long. You can do it sliplessly. If you need to, if you have two uplink providers, two playout providers that you need to check against each other, you can do that. The other point is, once they're synchronized, we can start comparing the individual video frames and understand when there's a problem. If the probability that two different playout systems playing the same content are going to have a problem at the exact same point in time is extremely low, especially if they're different technologies. This allows us and allows our customers to automatically monitor the quality and the integrity of their playout signals, of their video. It's true monitoring by exception. We don't need a monitoring wall with 50 channels up there that one person's trying to watch and determine whether or not the right commercial went to the right market at the right time. We can automatically determine, are we sending out a good quality signal? We have one playout system checking another one. And so when we can automatically monitor those and present only errors when they occur, it allows our customers to focus their engineering staff on exactly the parts where they need to stay focused on. And oh, by the way, we can record those errors and provide more technical detail at the time. Lip sync error correction. This is not a new problem. This is not necessarily a new solution to that problem, but it's possible. Fingerprinting the audio and video separately, we've been told a number of times that this has been done. Okay, let's get it implemented. Let's get it out there. It's available. And one of the last aspects that I want to touch on here is a potential benefit is synchronizing the second screen. Being able to deliver metadata relevant to the program at the right time to a second screen is immensely valuable. Whether this is advertising, branding information, where do I go to buy something, whether this is sports statistics, whether this is a learning app on a child's program, where the program's asking the kid, select this particular object, learn your colors, select the green circle. The green circle shows up on their tablet along with a few other things. Being able to synchronize that is important. The nice way we're doing this with fingerprinting, if that shows DVR'd and they come back and watch it 2 days after it's aired, we still have the fingerprints on storage. We can still know exactly where they are in that program segment, and we can still deliver the same information. So being able to take a look at how we deliver metadata gives us the options to do more with it than what we've ever thought about doing in the past. I'm not smart enough to come up with all the use cases that we're going to be able to do with video in the future, but I do know we need a better method for communicating and delivering the metadata associated with video programming that will enable those future use cases. So with that, I want to thank you for staying. You guys are my hero. We got a few more minutes. We have time for questions. So if there are any questions, please.
And please state your name and where you're from.
Thomas Edwards from Fox. I am a bit concerned because a lot of your motivation has to do with poor engineering by transcoder vendors that really should not be munging the timestamp across a group of different media flows. But be that as it may, the good news is SMPTE has the fingerprint SMPTE 2064, which was developed originally for audio-video synchronization. You know, it's not a forensic watermark. It's not something you'd use to go track down pirates or something, but it is perfect for this type of use case where you've got very high-quality media on both sides of the equation when you're looking for the fingerprints.
Thank you for bringing up the point about the encoders. One of the things we've seen is the way we're doing it now, the standard is evolving so quickly, the encoder manufacturers simply can't keep up. And diving into specific fields of a specific type of SCTE-35 message to alter the PTS or to dig that out, simply the firmware manufacturer, the firmware updates just can't come out fast enough. Nor do most of our customers want to upgrade their firmware on their encoder after they know it's working to do the primary job, which is encoding video and audio.
Just to add to that, you know, I agree with you, Tom, but the reality is that there are literally hundreds of different transcoding scenarios now, and you know, people are trying to make money here. To turn around and say, hey, you know, you're not compliant with the standard, you've got to fix your system. It starts with a conversation with people who've got, you know, all sorts of development priority as well as a long list of bugs that they need to fix. It's just not practical to expect them to fix these problems, and these are real problems. These are, you know, we've not made these problems up. These are problems that we have customers complaining, and their first complaint is always, hey, your SCTE-35 messages are not good.
We know of one station that converts their signal back to analog so they can apply graphics, believe it or not. SCTE-35 doesn't survive that conversion.
Alex Giladi, Comcast. So what you are doing on the technical side is you are looking at you are detecting scene changes, and you are using the pattern of these changes to mark the location, right?
Yes.
So on the receiver side, this means that if you go and put some sort of client that does this, you need access to the raw pixels, right?
Yes.
We've run scenarios where looking at HDMI video and can
yeah, but how would this exactly work? Exactly work with premium video. You are not supposed to be able to access raw and encrypted pixels unless basically you are inside a secure path, or it is you are within a CDM. Which
the algorithm's light enough. Smartphones and smart TVs can do it, and the fingerprint data rate is like 2 bytes per second, so it's not moving a whole lot of data.
No, the problem is that that unless you integrate with something that is secure, you are not running in a secure domain. You cannot be trusted with raw pixels, if I understand the problem correctly.
No, you're right. I mean, you have to have access to the uncompressed video, and for that matter, audio as well, in order to be able to detect the changes between frames. But then again, if you're going to monitor the video along the path, you have to have access to the uncompressed video and audio so that you can monitor it.
Not necessarily. If you never encrypt SCTE-35.
I missed that. Say that again.
You don't encrypt timestamps. You don't encrypt SCTE-35. So you don't have a problem with protected content.
Okay. Thank you for bringing that up. And another point I do want to make is, with this metadata, with the way 35 is, you can protect some of it. You can have different tiers. Some folks get some of it. There are going to be situations where you want to divide up who gets what metadata, and the current standard won't support all the scenarios that you're going to want to run. So being able to deliver just the metadata you want to deliver to a distributor is going to be important too, and not delivered metadata you don't want them to have.
Thank you.
Thanks. Any other questions before we get kicked out? Okay. Thank you.
Thank you.